In this video, we're going to look at sinking funds. They're also known as future value annuities. Now, a sinking fund is like a savings account for a business. It's a fund that is set up to replace an asset at the end of its useful life. In other words, if a company starts up, they will buy a fleet of trucks to do their deliveries, but those trucks are not going to last forever. So in 5 years or 10 years' time, they're going to have to replace some of those trucks. So what they do is, as soon as they've paid off the trucks, they will start up a sinking fund to start saving for when they might need to replace those trucks at the end of 5 or 10 years. Let's look at the first example. In this example, 240 equal payments of 800 Rand are made into a savings account monthly at the beginning of each month, starting immediately. We need to calculate the total accumulated amount at the end of 20 years if the interest rate is 9% per annum, compounded monthly. Let's look at it on a timeline. Because we're dealing with so many payments, it might help us to decide exactly what is happening when. Now, 800 Rand is paid monthly into the account at the beginning of each month. So I'm going to pay immediately, then I'm going to pay at the beginning of the next month, the beginning of every month until the beginning of the last month. So remember, T240 will be at the end of that last month. So 239 will be at the beginning of the last month. Now, if we have a look at this, what's happening, if I take that last 800 Rand, how many months is it going to earn interest for? It goes in at the beginning of the last month, so it's actually going to only earn interest for 1 month. So normal compound interest, but just for 1 month. If I look at the second last payment, that 800 Rand is going to earn interest for 2 months. So I'm going to add the next 800 Rand that's going to earn interest for 2 months. The third 800 Rand, or the third last 800 Rand, is going to earn interest for 3 months. And so we're going to continue. Each payment is going to earn an extra month's interest if I look at those payments from the end of the timeline. If I have a look at that, it makes me think that it's a bit of a number pattern, a series. So I'm adding various terms in the series because all of them look exactly the same except for that exponent on the bracket. So my first term in that sequence is 800 times 1 plus 0,09 over 12. Now remember that 0,09 over 12 is your interest rate at 9% expressed as a decimal, and it's happening monthly, so divide by 12. Then if I consider that equation as a series, how is each term increasing? Well, it's increasing by exactly 1 interest bracket. So the R value is an interest bracket, so 1 plus 0,09 over 12. And then they did tell me I was making 240 payments, so N is 240. So in financial maths, all of a sudden, if I look at each monthly payment, I end up getting a geometric series because each payment I'm going to just be adding, well, multiplying by an extra interest bracket. So if we just type this all into our calculator, our A value is 800 with an interest bracket. Our R is an interest bracket to the power of N, the number of years, minus 1 over R minus 1. Use your fraction button on your calculator and you should get a total of 538,316,82. Let's look at this example, and it's only slightly different. What's happening in this example is I'm still making 240 equal payments of 800 Rand, but this time I'm making them at the end of each month. And let's see what a difference it makes in the calculation. So again, let's look at it on a timeline just to see when these payments are happening. So if I'm making the payments at the end of the month, I'm making my first payment at the end of the first month, not at the beginning. And then I'll make a payment every single month until the end of the 240th month. And now if we have a look at it, if I look at it from the back, that last 800 Rand is actually not going to earn any interest. The deposit is going into the bank, and then we want the balance on the account. So that 800 Rand is not earning any interest. If I look at the second last payment though, it's going to earn interest for 1 month. So I'll add that to my investment. The third one is going to earn interest for 2 months. So I'll add that one. The next one will earn interest for 3 months. The next one 4, etc., etc. So again, what I've got is a geometric sequence or geometric series because I'm adding the terms. So in this case, my first term of my sequence is just 800. So A is equal to 800. How is each term changing? It's changing by one interest bracket. So 1 plus 0,09 over 12. And they told me I was making 240 equal payments. So N is 240. If we substitute all of that into our formula, we end up getting 534,309 Rand and 50 cents. So it's quite a bit less. Because those payments are going in at the end of the month, I'm actually not earning interest on that last payment, but it actually makes a significant difference. Now let's just look at the difference. First of all, your N value, if you want to calculate it, you can calculate it with your last term minus your first term plus 1. And let's look at the difference between making the payments at the beginning and making the payments at the end. Now in this example, my payment was 800 Rand. So this time, let's just think of my monthly payment as X Rand. So if my monthly payment is X Rand, that A value in my formula will include one interest bracket. Because remember, if my payment starts immediately or at the beginning of a month, the last payment still has to earn interest for that month. So the A value will include an interest bracket. But if my payments start in 1 month's time or happen at the end of a month or year, then that last payment doesn't have time to earn interest. So the A value in my formula is not going to have an interest bracket. So that is a sinking fund. So we look at it as lots of different little investments that we're adding together, and they form a geometric sequence. But it's known as a future value annuity. And why is that? It's because I don't have any money in the beginning, but I'm saving my money for the future. So I'm going to have a balance in my account at the end of the payment period, not at the beginning, not like a loan. With a loan, I get my money immediately, so I get all the money in my pocket straight away, so I get the money in the present. But with a sinking fund, it's a savings account. I'm saving for the future. Now, on your formula sheet, you do get the future value formula. And let's just compare these two formulas. So you have been taught using the SN formula for a geometric series, but you can use the future value formula as well, because A just represents my monthly payment, which is your X. Your R is your interest bracket, which is just 1 plus I. And then in the denominator, R is your interest bracket, which is 1 plus I. And then you've still got minus 1. And in the denominator, those ones cancel out to give you your proper future value formula that appears on your formula sheet. X bracket 1 plus I to the n minus 1 close bracket over I. So you can use either approach. Both work very, very well. Thanks for watching Max Maths. If you liked what you saw, please like, share, and subscribe.